Hey there, and welcome to a psychology video to help you in the Unit 5 Cognition chapter of our study. This is a tough video to make because there are normally a lot of demonstrations and activities that I would do along with this lesson. So it's on problem solving and decision making. And there's a lot of example problems that I would have given in class. And then we would have together talked about what was preventing us from actually solving those problems. But in order to make this a fairly short video, or at least a faster content delivery, um, many of those problems will not really be discussed. But again, briefly, it's going to be on problem solving, uh, particularly with the problem solving and decision making that goes on in AP Psych, Unit 5 Cognition. So, with that being said, here we go. Let's see if I can get this to. Okay, that works. There's three types of problems. So you have inducing structure, arrangement, and transformation. This basically means you're going to have problems about analogies, completion in a series. You've got arrangement, which is like playing Scrabble, trying to arrange things in a certain way. So an anagram is an example of that. And then transformation, which involves sequencing. I will show you some examples here. So you've got some analogies. The merchant is to sell as the customer is to buy. Lawyer is to client as doctor is to patient. So that's one of the first types, again, inducing structure. Next, we go to arrangement. Arrangement is like anagrams, playing Scrabble. Like I said, there's a couple words here you can unscramble. If you want to do it, go for it. Pause it if you want to think about it. And assuming that you did pause it, now I'll give you the answers. You got water and joker. So those are anagram type. And then lastly, we have transformation. This involves sequencing, and while I'm not going to discuss this problem, it is a famous example, the Hobbits and Orcs problem. In order to solve this problem, you have to basically lay out a certain series of steps in the correct order. All right, we're not going to be looking at that one. Unfortunately, not looking at this one either, but yeah, you can pause if you want to figure it out. One of the reasons you could not probably have figured out the last answer is due to something called functional fixedness. And the solution to the previous slide, if you want to go back and look at it again, I'll pause for a second if you want. All right, so basically what it is that the screwdriver is very vital. You have to actually tie a string to the screwdriver and turn the screwdriver into a pendulum. So it serves as a weight, and this allows you to actually swing the string that's going to be out of reach. So you hold one string as far as you can after swinging the screwdriver tied to the string, and this allows you to grab it when it swings back your way, and then you can tie the strings together. So functional fixedness is thinking about the screwdriver in another way. We don't tend to do that, and that's part of the problem. Functional fixedness is to say, well, the screwdriver's main job is to serve as a tool to screw in a screw. A hammer's job would be to hammer in a nail, but these items have other functions and other utility that can be used. So this is a barrier to our problem solving, functional fixedness, and unfortunately, this is not the only one. All right, we got a couple other problems here. This is the 9-dot problem. Again, not going to be going over this one right now, but maybe in a future video. And then we've also got the matchstick problem. You can try and figure these out if you want, but I'm just going to explain what generally stops people from solving these problems, or most people. And so, sorry about some of these. Some of those things are having ideas of mental set. Mental set means that you're going to try things that have worked for other problems, and because it might have worked in the past, you think, hey, I could probably do it now, but actually that could come back to hurt you in these moments because these are probably problems you've never seen. Also, some people experience a burst of insight after thinking about a problem for a little while, maybe taking a break. There's what's known as the incubation effect, where taking a break could actually help you with problem solving. But sometimes you kind of have an aha moment where you're solving a problem and you think like, oh, most common solution, there it is right in my face. And so when you suddenly discover that in the moment, it's called having a period of insight. Usually this can happen after somebody has placed barriers upon themselves that might not have been necessary. So if you went back and looked at the problem space area of the 9-dot problem. A lot of people look at that problem and they see the box and they're thinking, okay, I got to stay in the box. But it doesn't say anything about staying in the box under the directions. So those are unnecessary constraints that you've placed on yourself. And after thinking about it for a while, it is possible that you have that aha moment, burst of insight, and then, hey, guess what? You can solve it. Good job. This is a problem about insight. You can set this up if you wanted to try it by basically drawing 6-letter U's side by side and then follow the directions and see if you can figure out the one correct move that solves the problem. And there's the solution. Sorry about that. Probably should have given some warning, but you know how it is. Also, another insight problem. You can read over this one. Hit pause. It might take you a second, but you might end up thinking about it, and there's only one logical solution here. So again, you can pause now if you want. I'm going to go to the answer, which is this one. All right, so many approaches to problem solving. Like I said earlier, the problem space is pretty important. This is some more common sense stuff here. Trial and error using algorithms. Take a word that you want to unscramble and alter one letter at a time and go through as many possibilities that exist. And then eventually you're going to get the one that unscrambles the word. Now that's going to take forever, but it does work. So instead, some people may prefer to use heuristics. A heuristic is a rule of thumb that you would use to solve up your problem solving. So for example, you could say if it's dealing with anagrams and unscrambling stuff, you could say, hey, certain letters are here, Q's and U's. What might be a logical order for those? Okay, is a U before the Q? Probably not, but is a U usually following a Q? Most likely. So use tips like that, and those are heuristics. We'll look at some special ones in a few slides. When it comes to problem solving in America, when we compare ourselves to the rest of the world, or as a Western hemisphere versus Eastern hemisphere kind of problem solving, we tend to struggle with certain elements of problems that people of the Eastern hemispheres not so much. A lot of it has to do with how you look at elements of a problem and focus only on one aspect of a problem, or the parts of a problem versus taking in the whole problem. And typically, as Westerners, we see individual parts and we sometimes can't actually see how they work together as a whole. Whereas Easterners, people in the Eastern Hemisphere, tend to see a whole problem, whereas we see as Westerners the individual parts. So I'm going to go through a bunch of slides here. Not going to go over any of these things. I just was a little lazy and didn't erase them out of my presentation. So now we go to the second half here, which is on decision making. It's exactly what it sounds like, but what kind of factors are involved with your decision making? That's something that we can take a look at. So one of the things here, this is a pretty important theory of this Unit 5 on cognition. It's from Herbert Simon, and it's called the theory of bounded rationality. What's taken place here is people make a decision, oftentimes a irrational decision. It's a less than optimal decision, so it wasn't you at your best by any means. But you make this decision off some quick information, some short facts, something that's not really detailed, and usually the end result is not in your favor. This is considered an irrational decision because you're making it with such a small amount of information in the first place. And so this is directly tied to something called the gambler's fallacy, which is basically an idea that if you're gambling or playing a lottery or something of that nature, because you haven't won in a while, you are suddenly more likely to win. If you're playing roulette and you bet on black because red has been winning for the last 50 rounds in a row, you're thinking, well, black hasn't won in a while, so I'm going to bet black, or vice versa. Red hasn't won in a while, so I'm going to bet red, or odds or evens or whatever. You're no more likely to win statistically than the previous round or the round before that or before that. And so that is the gambler's fallacy, when you think you have a better chance of winning because something hasn't happened in a while. And this is like textbook example of a theory of bounded rationality. You're making an irrational decision. Hey, I'm betting red because red hasn't won in a while. And the result could be less than optimal. You might lose it all. Some strategies that people use for decision making. You may be sitting around with friends, or depending on who's watching this, coworkers, and trying to make a decision, but what ends up happening is people end up talking in circles. You can't come to a decision. Maybe you're trying to figure out, hey, what do we want to have for dinner? Where do we want to go out to eat for lunch? What do we want to do for our activity for the evening? Whatever it's going to be. People talk in circles. So there are some ways to go around that. Part of that is using what's called an additive point system. Maybe you are making a decision about where you might want to go to college. All right, how do you compare those colleges if you get into two fairly similar colleges of financial status and prestige and location and majors offered and distance away from home or distance close to home if that's what's important to you, or all these other factors. You use the additive point system to kind of weight those factors and how they are prioritized. So if there's one that is really important to you, like, hey, I want to be way far away from Harrisburg, North Carolina, or I want to go to the school that is the largest campus or whatever, then you give certain ideas a weight. And when you're comparing, you should end up with a result that is separating your answer so you can pick the best choice. Another option is to use elimination by the aspects. So you create a list, almost like a pros and cons list, and you're trying to eliminate the factors that are less alternative, or excuse me, less attractive. And so as you're alternating between these factors, you decide, what is going to be appealing to you and what's desirable and what's not. And you start to, because you've factored out all these ideas, you eliminate the options that are less desirable or less attractive. Um, this one is kind of speaks for itself here. Not much to really add. People generally don't do well with uncertainty. They would prefer to avoid it. So trying to take the emotions out of decision making can be really tough. We process emotions really fast, faster than language. And it's very, very difficult to not have an emotion factor into a decision. Um, yeah, that's all I really got to say on that. So getting into this next idea, it's about really risky decision making because that's kind of separated in psychology between a regular decision and then a risky decision. So like the example says, imagine that you're running late for an appointment. You're faced with the decision because you're driving. Should you risk a speeding ticket to get to this appointment on time? And I don't have the magical answer for you there. I mean, there's certainly people who avoid speeding tickets their whole life. Um, it took me about 12 or 13 years of driving before I finally got a speeding ticket, and I thought it was really unfair, but it happens. But in this case, what do you do? How do you decide? Am I gonna speed? Am I not gonna speed? What's the correct choice? And so this is part of risky decision making. A lot of what's taking place here is what's on your mind, what information's coming to mind. Do you know anyone that has gotten a speeding ticket recently? If you're in the area, do you know anyone in that area who's got a speeding ticket recently? And we ultimately decide what the outcome is worth for us. So this is called subjective utility. And for me, I would say that speeding is not worth it to me to get to an appointment. I'd rather just be late, although generally I'm the kind of person that always leaves with enough time so that I don't have to worry about speeding. But, in the example, I would say that speeding is not worth it to me at risk of a ticket, especially since here I live in a small town where there are going to be police who would be hiding off the main roads looking to fill quotas or pull people who are actually speeding. So not worth it to me to go somewhere like the eye doctor or the dentist. But somebody else in another setting, they might say, hey, it is worth it to me. I've got a big job interview. I can't be late. And, again, I could criticize that example for other ways, but not going to do that. But that's the idea. So what's coming to mind here? Two other pretty key terms. I see these pop up on AP exams pretty much every year. These are special forms of heuristics and how we evaluate probability. And so one thing known as the availability heuristic is when we estimate probability of an event on the ease with which relative instances comes to mind. Okay, so kind of a word salad there, but basically it means before you make a risky decision or any decision and you're thinking about probabilities, what information is available? Like I said earlier, if you know somebody who's gotten caught speeding recently, that's available information. So that's something that is going to factor into, do you decide to speed or not? And have any of your friends got the ticket? Another example that you might see is going to say, if I ask someone to estimate the divorce rate, if you know a lot of people who are divorced, if your own family's divorced, if you are a product of a divorced household, if you have neighbors who are divorced, people in your community who are divorced, you get the idea. Um, you might estimate that it's a higher divorce rate than what actually exists versus the opposite. If you don't know a lot of people who are divorced, if you don't know, if it's just not really around you, you might underestimate the divorce rate. So again, this is available information coming to mind, and hopefully you can start to see how that could impact how you might judge a probability. On the other hand, we have the representative heuristic. This time around, we are basing probability on how similar it is to the prototype. So are you more significant than the prototype? If I flipped a coin, heads or tails 6 times, are you going to see 6 heads in a row, 6 tails in a row? Are you going to see them alternate back and forth, 2 heads at a time, 2 tails at a time, heads, tails, heads, tails, heads, tails? What outcome are you expecting? Well, statistically, the answer is that any option is the same. It could be all heads, all tails, heads, tails, heads, tails, heads, tails. But what is the prototype? What would you expect to see? What you would probably expect to see is an alternation between heads and tails, not 6 tails in a row. That's just a prototype, though. Statistically, it is the same, but you consider stuff like this. I'm going to give you another example. So imagine that you meet a slim, short man who wears glasses and likes poetry. What do you think his profession would be? Is he an Ivy League professor or is he a truck driver? You take a moment and think about it if you want. Again, think about the model. What do Ivy League professors look like? What do truck drivers look like? What is the prototype here for a professor or a truck driver? Now, it might surprise you to know that the actual answer here is that this is describing a truck driver. There's way more truck drivers than there are Ivy League professors. And so the probability that the person is a truck driver is actually far, far greater than the professor just because there's so many more. But again, prototype and representative heuristic is impacting how you evaluate this probability. There's some more stuff on availability heuristic. All right, I already kind of covered this. We have a base rate fallacy where we tend to apply base rates to ourselves, but ignoring the base rates to ourselves at the same time. So, for example, you might see right now coronavirus is actually a perfect example. There's going to be some base rates of infection once there are even more people who are publicized to get the virus, but we tend to undermine personal risk for ourselves. And so that means I might be the kind of person who thinks I'm safe and not going to get coronavirus because of it applying to me. This is a base rate fallacy. We also have something called the conjunction fallacy. You may see here there's a lot of fallacies in this unit. It can be a little tricky. But conjunction fallacy is people estimating the odds of two uncertain events happening together are actually greater than the odds of either event happening alone. And that's, again, another one to think about here. We got base rate fallacies, we got gamblers fallacies, we got conjunction fallacy. There's a lot of fallacies. I promise, though, we're almost done. So in forms of heuristics as well for decision making, we have what are called fast and frugal heuristics. And basically what we're saying here is that, kind of like the theory of bounded rationality, we use as people, as organisms, as animals, very quick decisions making, very quick heuristics. They're not perfect, but usually they work. Um, Stereotypes are not great, but people make them for a reason. People make decisions that are less than optimal sometimes, but part of the reason they do that is because many times they've found some short-term success. And so we have to be mindful that there are kind of fast and frugal heuristics. There's a fast way that we've gone about things traditionally, but we may actually use a more effortful processing and effortful thinking if we slow it all down. And these are things that can exist in tandem with one another. So here we are at the end. We have the real life applications. Already explained the gambler's fallacy, but there you can see it. As people, we do overestimate improbable events. Are you more likely to die in an asthma attack, or are you more likely to be eaten by a shark? Shockingly, people make this mistake, but asthma is a way bigger killer than shark attacks. but people sometimes go to the beach and they're in fear of the shark attack way before they're in fear of the asthma attack. And this is often supported with confirmation bias. We tend to seek information that is likely to support our decisions and beliefs. So, like, I'm probably not going to go through the news and click on a story about somebody dying from an asthma attack, but an appealing story about a shark attack or a shark bite, I might click on that just to see what's going on. And then I'm confirming, oh, yeah, shark attacks are really dangerous. And that's just not really the case. And there's many other examples where you could have confirmation bias, where you see something and then you were kind of like, oh, yeah, that is kind of what I thought. And that's really exactly where you see the confirmation bias. I'll leave you with this as I close this down. But again, unfortunately, we're not in class to go through all this now. You're walking in the desert and find a man lying face down with a pack on his back, dead. How did he die? Unfortunately, you have to figure this out through yes or no questions, which you can't ask me. So I'll just have to tell you after a brief pause. And the answer is this man was a skydiver. He jumped out of a plane and his parachute didn't open. So he died. Adios. Stay safe.